Time series graphs, line graphs, and misleading graphs. Objectives. The students will be able to construct and analyze time series graphs. The students will be able to create a time series graph using Google Sheets. Actually, you'll be making more than one. The students will be able to determine the factors that make a graph misleading. What is a time series graph? A time series graph or a line graph is used to show how data changes over time. There is a graph there to the right, and we're going to look at that for required components. Of course, you've got to have a title. So the specific title in that is birth rate for children per family. Next, you need contextual axes labels. So not just number, but we had number of children on the y-axis and years on the x-axis. You must be consistent. Your scale needs to jump by the same amount every single time, and your y-axis must start at 0. Making a time series graph, example 1, the table shows the temperatures outside your school during one day. Display the data using a line graph. So at 8 a.m., and I already have all the axes, labels, and titles and scales there for you. At 8 a.m., it was 63 degrees. So we have to estimate where that is, put a dot. At 10 a.m., it's 66 degrees, a little bit higher. At noon, it's 72, so above 70, less than halfway. 2 o'clock is 75, so halfway between 70 and 80. Little bit higher at 4 p.m., that's 76 degrees, and then at 6 is 74. Connect the dots in order. When did the greatest temperature change occur? Well, that would be the piece, the segment with the highest slope. So that's between 10 a.m. and noon. Here's that same graph. What is the general trend in the temperatures between 8 and 4? Okay, so we're not including the 6, but between 8 and 4, it looks like the temperatures are increasing. So between 8 a.m. and 4 p.m., the trend is that the temperatures are increasing. Time series graphs analysis. When analyzing a time series graph, you will make comments on features such as long-term trends, up or down changes. There could be seasonal effects, cyclic behavior, so going up and down and up and down and up and down, random fluctuation, and short-term trends. Analyzing time series graphs. So we have a graph there for you. We're going to use it. It shows the number of turtle nests recorded in Cape Lookout, North Carolina. Old data from 1990 to 2000 to answer the given questions. And I have everything there for you. But do notice I have in blue underneath the graph, the scale's jumping by 2 years each time. So just make note of that. Between which 2 years did the number of nests decrease the most? So the steepest decline is right there. And like I said, there's 2 years between each one. So 1999 would be there in the middle, and then there's 2000. Between which 2 years did the number of turtle nests increase the most? So the steepest climb, which would be this part, this segment, and that starts in between 96 and 98. So that would be 1997. So between 1997 and 1998. In which year was the greatest number of turtle nests recorded? So that would be the peak right there at 1999. And if we estimate the number of turtle nests recorded in that year, now notice the boxes are going up at 50 a time. So that is just under the 250, but we're going to estimate that to be 250. Analyzing the data table, example 2. The table shows daily low and high temperatures for Lugoff, South Carolina from January 1st to January 14th, 2025. I collected this data myself, so it is not real old. Which date had the lowest low temperature? So you got to scan that second column for the lowest of the lows. Analyzing a data table, example 2. The table shows daily low and high temperatures for Lugoff, South Carolina from January 1st to January 14th, 2025. New data. Put this together myself. Which date had the lowest low temperature? So low temperatures is that second column. You need to scan down through there, and the lowest of the lows is on the 8th of January is 18 degrees. So which dates, this one's plural, had the highest low temperature? So we're still looking at the lows, but we're looking at the highest. There is there, and 36 happens twice. So on January 1st and January 6th of 2025, it was 36 degrees for a low temperature. Which day had the lowest high temperature? So the next column over there, we're looking for the smallest number, and it looks like January 10th with 32 degrees. Now you want the highest high temperature. And it doesn't say plural, so there's got to be just one that is the highest, and that happened on January 6th of 2025 is 61 degrees. Same table. Which dates had the largest difference? So I did have a column over to the right. I added the difference between the highs and lows. So how much the temperature changed within the day. And the largest difference, so scan down through there, find the biggest number, and I think there are two 28s, January 3rd and January 8th. Which date had the smallest difference, so the lowest change throughout the day? And we're looking at that 13. So on January 10th, the temperature only increased 13 degrees. Now I made graphs for both of these. And I do have a legend there for you. You have to do that for time series graphs. You will be making some time series graphs where you are having more than one set of data shown at the same time. So the blue are the lows. Makes sense, they're lower than the red, and the red are the high temperatures. So which way is easier to find the lowest low and the highest high daily temperature? Pretty sure it's using this graph. B, which way is easier to distinguish patterns in the data? I think it's much easier to distinguish patterns when you're using the graph instead of looking at numbers in a table. Appropriate data displays. We've already talked about some of these. Circle graph is when you show data as parts of a whole. Bar graph compares data in distinct categories, so it's usually categorical data. Line graph shows how data changes over time. Stem and leaf plot, which we already covered, shows data in numerical order. Appropriate data displays. Example 4, table shows the approximate area in millions of square feet of each of the 7 continents. Which type of data display would be appropriate to compare the areas of each continent to the total area? So part to whole is going to be a circle graph. Another one, example 5. This table shows the amount of snowfall during a blizzard. Which type of data display is the best to show the accumulation of snow over time? So we're going over time. That would be a line graph. Avoiding misleading graphs. Don't just believe that all visualizations always convey correct information. Don't get trapped because of the graphical designs, complex graphs, bold titles, and catchy labels. Check if the vertical axis has a baseline of 0. That is so very important. We're going to be using that a lot. Check whether the data points are omitted or not. That's something we'll be looking at. Check if the pie chart completes the circle of 360 degrees with a total of 100% data labeled on it. Recognizing misleading graphs, example 1, how is a graph misleading? So look at the graph. Very poorly made. There's 2 bars with 17%. They're not the same height. So there's 2 bars with labels of 17% and they have different heights. Also, look at that 13 is almost the same as one of those 17s. And that second 17% winner is more than half of the 53. So all kinds of wrong in this graph that can be misleading. Number 2, how is this graph misleading? Check all that apply. So the category with the lowest percentage has the tallest bar. Yikes, it does. Not at all is 13%. It is the smallest percent. It is the tallest bar. The bar percentages do not total to 100%. Well, we would need to calculate those, add them up, see if it works. Must work. There isn't a bar for somewhat, and yet it represents 28%. How in the world? The bar for 34% looks almost double that of 25. And it's smaller than 13. Number 3, check each true statement about the given bar graph. Vertical scale does not jump consistently. Well, it starts at 0, it's going up by 20 every time, so that's fine, that's not a problem. Vertical scale does not start at 0. Well, it does start at 0, so that's not an issue either. There's not a label for the vertical axis. Yeah, we should have a label. There's not a label for the horizontal axis. That doesn't have a label either. But do notice, since each bar is a category, like all good bar graphs should be, the percentages are the percent per category and will not add to 100%. This is not a circle graph. This is a bar graph. Example 4, check each true statement about the given bar graph. The percentages for the sectors do not total 100. Yes, they don't. Way over 70%, 60%, 63%. All 3 of the percentages given are over 50%. Yeah, yet none of them are over half of the circle. Okay, bad one there. No label for the vertical axis. It's a circle graph. There isn't a vertical axis. And the next one, vertical axis does not start at 0. It's a circle graph. No vertical axis. The circle graph is a slanted view. Yeah, don't do that. 5, check each true statement, and it's the warmest years on record. Contiguous U.S. So I looked it up for us. Sharing a common border, touching. So their specific example, which works for us, is the 48 contiguous states. So we have a bar graph. The bars are not the same width. They should be. They are. We're okay with that. Years are not in order. Ooh, we're going from 1921 to 1999 down to 1934. So they have those all mixed up. There isn't a label for the vertical axis. A lot of years are not included. And bar chart should be for categorical data, not years. So maybe a line graph would be better. But that x-axis, those years are not in order. That causes issues. They are misleading you. They're showing you a trend of increasing the entire time, but the years are not in order. Here's number 6. Check each true statement about the given bar graph. Bars are not the same width. Well, they are. There's no label for the vertical axis. Well, there is. First graph exaggerates the increase by not starting the vertical axis at 0. True. So the bars are going up, or the labels, the scale is going up by 1,000 each time. But from the bottom to that first one is a difference of 80,000. So that causes problems. It exaggerates the difference. Plus, they don't even have titles. Example 7, check each true statement about the given circle graph. There's no mistakes. That would mislead you. I see a couple things wrong. There's sectors that do not include percentage for their category, and the title should probably include the word time, the time spent on each of those events, breaking down the day. Example 8, we are given another bar graph. There's no mistakes. That would mislead you. Well, we need to look at the graph. Let's come back to that. No label for the vertical axis. Well, there is a label. Vertical axis does not start at 0. It does, and it does jump consistently. No label for the horizontal axis. Well, it has that too. X-axis does not have the temperatures in order. Ooh, at a closer look, that is true. So there are some mistakes. These bars are in the wrong order, so we get the wrong trend. It's probably not up and down if we put those temperatures in order from lowest to highest. Here's another one, example 9. What principle does this graph fail? Wow, we talked about this before, and that's the area principle. They're trying to show them as bar graphs, but the taller the shape gets, the bigger the shape gets. So it distorts the look of the graph. Let's see, there's two big factors that make this graph misleading. What are they? Look at the graph. Look at all the pieces. Y-axis scale does not start with 0. Okay, that's a given. Vertical axis scale is, wow, look at that. Very inconsistent. You went from 300,000, there's a gap to 500, then 600,000. But the space between that 600,000 and the 700,000 is not the same gap as between the 500,000 and the 600,000. Boo. Omitting the baseline is one way to mislead graphs. This is known as a truncated graph. In most cases, the baseline for a graph is 0. Look at those two graphs on the left. The one that's in the green does not start at 0, and the one that's in the right does start at 0. Just because the percents are written on the second one does not necessarily convey different information than the one on the left. We could have those percents written on top there as well, but look at the one on the left is starting with 50. It makes the smaller differences between groups seem massive. Group A looks much larger than Group B and C, but the accurate way to draw it, starting at 0 and jumping up by the same amount each time, makes it more accurate description of the data. Notice the differences between the groups does not seem as drastic. So some writers can skew how data is perceived by making the baseline a different number. Manipulating the axes. So basically the same kind of thing on this. Notice for the test dates and grades, they're starting at 80%. So it looks like it's going up a bunch. But really, if we have a different scale and it's starting at 0, the difference, it is increasing, but it's not increasing by a lot. The next graph, KFC's crispy chicken tenders. Okay, so we have calories. This is a horizontal graph. So it exaggerates the differences because our starting number on the x-axis is 590 instead of 0. Manipulating the y-axis, expanding or compressing the scale on a graph can make changes in data seem more or less significant than they actually are. And look at how messed up the graph in red is. You're starting at $2.50. You go up like a box and a half to $3. And then look at, there's a huge jump to get to $3.25. The ones on the left, they start at 0, except the temperature one. But the ones with the years, they both start at 0. But because the one on the left, we're going all the way up to 40, which is unnecessary, and the one on the right goes only up to 15, you show better trends in the data. It's not exaggerated or lessened the trend. Though high temperatures, I don't like that little zigzag thing. That means you're truncating, and you shouldn't do that. Cherry picking data. Writers may only include certain data points on their graphs to reinforce their narrative. This can create a false impression of the data. So if we look at the purple, and they have some certain months picked out. It's from May, probably 2000. And let's see, it's increasing, but it only goes to August. But the one on the right, instead of doing 4 months, they're doing 1, 2, 3, 4, 5 years. So the one on the left looks like it's increasing. The one on the right looks like it goes up and then comes down. So vastly different based on the scale that was chosen. Cost of gas. Oh my, on the x-axis. Fox News, boo on you. Last year price, $3.17. Last week was $3.51, and current. So huge differences between those three things. Not finding misleading graph. No, fixing them. Explain how you could redraw the graph so it would not be misleading. Look at the graph. Okay, they have a pretty little picture there, but I think they are letting it be an excuse for not starting at 0. So draw the vertical scale with equal spacing between marks so that the distance between 0 and 18,000 equals the distance between 18,000 and 36,000. Let's fix another one. Explain how you do that. Look at your graph. And once again, it is not starting at 0. So draw the entire vertical scale on the graph. The vertical axis does not start at 0, so differences in water consumption seem greater. Another one, example 3. How can we redraw it? Same mistake. It happens a lot. You need to start at 0. So draw the entire vertical axis on the scale. Vertical axis is broken. Okay, don't make it with that. So the differences in fair appear to be greater. It is distorted. It's exaggerated because of the scale.